Mutual width of their energy gap. First thing. Second, in insulators, what you know about valence band? And in insulators, valence band is completely filled and conduction band is empty. Forbidden gap band is in the order of 5 electron volt to 15 electron volt. Check. So conduction band is filled with electron. No, conduction band is empty and valence band is filled with electron. Therefore, option B. Okay. Hello.
Yes, sir.
Next, third, the valence of impurity added to germanium crystal in order to convert them into a p-type semiconductor. So for p-type, impurity from third group is added. Impurity from third group is added. So they have got 3 electrons in the outermost orbit. That is option D. Option D.
Done, sir.
Fourth, in semiconductor, concentration of electron, it is denoted as Ne, is 8 into 10 raised to 14, and that of hole is 5 into 10 raised to 12. So Ne is greater than Nh, you can see clearly. If Ne is greater, it is n-type semiconductor. Okay. Fifth, the temperature dependence of resistivity of semiconductor. Rho with temperature. If it is semiconductor, then it exponentially decreases the resistance. So option C. Temperature increases, resistance decreases, that means resistivity decreases. Sixth one. The donor atom electron have an energy level. Donor means it will donate the electron, that means becomes conduction. So donor atom electron has energy level close to conduction band so that it can send the energy faster. So below the conduction band, A option. Slightly below the conduction band so that it can release the electron. Seven. At ordinary temperature, electrical conductivity of semiconductor is in the range of, at which temperature? Is it normal temperature? Hello? Hello?
Ordinary temperature.
Ordinary temperature means our room temperature, normal temperature. Does it behaves like conductor or it behaves like insulator? At normal temperature, it behaves like what?
Conductor.
At higher temperature, conductor, lower temperature, insulator. This way it is, no? That means its conductivity is less, no? Resistivity is more. So conductivity is less. Less means power will be negative or positive. Hello? Power will be negative.
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 Option C. This is factual. You have to remember this. Have you done till 7?
Yes.
Yes, sir.
8. For germanium crystals, forbidden energy gap. For germanium, forbidden gap is nearly 0.72 electron volt. And for silicon, forbidden gap is 1.1 electron volt. So we have to convert into joule. So for germanium, forbidden gap band is 0.7 electron volt is 1.6 into 10 raised to minus 19 joule. 6 into 7, 42, 11. 1.12 into 10 raised to minus 19, option A. Right. Nine. First complete this, the ninth I'm explaining.
Done, sir.
Eight. Ninth one. A germanium specimen is doped with aluminium. Concentration of acceptor, that means hole, is 10 raised to 21. If the intrinsic concentration of whole electron pair, intrinsic means pure, 10 raised to 19, then what is concentration of electron? So if you recollect, I had written this formula, Ni square is Ne into Nh. So 10 raised to 19, the whole square is concentration of electron into 10 raised to 21. 19 into 2 is 38. is Ne into 10 raised to 21. That means 10 raised to 38 upon 10 raised to 21. That will become 10 raised to 17. 10 raised to 17 option.
Done. Ji.
If the electron mobility mu of electron is 3900 and conductivity, that is sigma, is 6.24, then impurity concentration will be how much? Ne is how much? Sigma is mu E into Ne. Therefore, Ne will be sigma conductivity is mu into sigma upon mu E. That is 6.24. And this conductivity is sigma, electron mobility is this. So concentration will be how much? Hello?
Yes, sir.
So electron mobility is mu 3900 they have given. Sigma is 6.24 per centimeter. Impurity concentration, that means electron added Ne will be how much? N type means electrons are added as impurity. So sigma upon mu into Ne. Electron mobility is given by 6.25 mole per centimeter. There is some power error, I think. Just leave for the time being. This one. 6.25 into 10 raised to कुछ power change शायद है. 11. Contribution due to electrons and holes. Contribution of total current due to electron and due to hole are 3 by 4 and hole 1 by 4. If the drift velocity is 5 by 2 times of electron that of hole, then the ratio of concentration of electron to that of hole is how much? Current formula is drift velocity Vena. So current due to electron upon current due to hole is drift velocity due to electron upon hole. Electron and hole charges value is same. Concentration of electron upon hole, area is same. So IE is 3/4, I hole is 1/4, electron is 5/4 that of hole into concentration of Ne upon NH. 4 will get cancelled. So 3/1 is 5/4 Ne upon NH. Therefore, Ne upon NH is 12 upon 5. 12 upon 5. 5/2 here. So that is nothing but 6 upon 5. 6 upon 5, option A.
Done, sir.
Next. Well, current produced at room temperature in germanium plate of area 2 into 10 raised to minus 4 meters square, having length thickness 1.2 into 10 raised to minus 3 meter, when a potential difference of 5 volt is applied across the faces. Concentration, current produced at the room temperature given, area given, length given. Concentration of carriers in germanium at room temperature is 1.6 into 10 raised to 6, and mobilities of electron and hole are 0.4 and 0.2. Formula is sigma equals to mu into mu of electron, n of electron, charge of electron. So, mu of hole, n of hole, charge of hole. Sigma is 1 upon rho. Mu of electron 0.4. n दोनों का सेम है 1.6 into 10 raised to 6. Charge of electron 1.6 into 10 raised to minus 90. Mu of hole 0.2. N of hole is 1.6 into 10 raised to 6. Charge of hole and electron are same. 1.6 into 10 raised to minus 19. 1 upon rho.
Yes, sir.
This rho, can you tell me in terms of R? It is R L upon area.
Yes, sir.
From here, R equal to rho L upon area. So rho will become RA upon L. Sorry, RA upon L. Okay. Now we can add this as common term. So it will be 0.2 plus 0.4, 0.6 into 1.6 into 10 raised to 6 into 1.6 into 10 raised to minus 19. Okay, followed? These are like 0.4x plus 0.2x. ना? तो 0.6 कर दिया L ऊपर ले लेता हूँ ये. R means V upon I.
Yes, sir.
16 into 16 is 2.56 into 10 raised to minus 13. I will go up. IL upon VA is 0.6 into 2.56 into 10 raised to minus 13. Copy this much first. Length is 1.2 into 10 raised to minus 3. Voltage is 5. Area 2 into 10 raised to minus 4 equals to 0.6 into 2.56 into 10 raised to minus 30. Point 6 into 2.56 into 10 raised to minus 30. 5 into 2, 10. 10 into 10 raised to minus 4 upon 1.2 into 10 raised to minus 3. 10 and 10 raised to minus 4 is minus 3. 0.6 into 2. So I equals to 2 into 1, 2. 2 2 is a 4. 2 is a 16 into 10 raised to minus 30. Yes, completed.
Yes, sir.
10th वाला ना गलती से तभी मैं इलेक्ट्रॉन का नहीं डाला था वैल्यू. 10th one again I am doing. 10th. Electron mobility is 3900, and its conductivity sigma is 6.24. Find Ne. So sigma equals to mu E Ne into charge of electron. So Ne is sigma 6.24 upon mu E 3900, charge is 1.6 into 10 raised to minus 90. So this will be equals to 6.24 upon 3.9 into 10 raised to plus 3 into 1.6 into 10 raised to minus 90. This if I take as 4, 16 fours are 64. So approximately this will get cancelled. So answer will come 10 raised to plus 16. Option D. Are you done with 10th?
No, sir, just a second. Yes, sir.
13th. In a PN junction diode, current in reverse biased condition is generally very small. Very true. Current is reverse biased is small, but in forward biased current is independent of bias voltage. Current is independent of bias voltage. No, it depends upon voltage. Reverse bias current is dependent on applied bias voltage. Forward bias current is small in comparison to reverse bias. No, first is correct. Reverse bias condition is generally very small. Current in reverse bias condition is generally very small. Means almost negligible. Which of the following statement concerning the depletion zone of unbiased state? Width of depletion zone is independent of material? No. It is dependent on the density of the impurities. B option. It depends upon impurities, that width. 15. Dominant mechanism in forward biased. Forward biased, it is diffusion. Reverse biased is called drifting. Forward biased diffusion, reverse biased is drifting. 16. Important one. A semiconductor X is made by doping germanium. If doped with arsenic, then it is P type or N type. Antimony, arsenic, phosphorus is N type, no?
Yes, sir.
And doped with indium, gallium, that is P type, okay? the two are joined as shown. So this is N type, this is P type are joined as shown. Now N is connected to plus and P is connected to minus. That means there is reverse bias.
Yes, sir.
Option, let us check what they have given. Yes. X is N type, Y is P type, and junction is reverse biased. X is N, Y is P, and reverse biased. Option D. Okay, done.
Yes, sir.
17th one. A 2-volt battery is connected across point A and B as shown in the figure. 2-volt battery is connected as shown in the figure. The current supplied by the battery when the positive terminal is connected to A. Positive terminal connected to A will be how much? Hello?
Yes, sir.
Positive connected to A, negative connected to. So this is reverse biased or not?
Yes, sir.
Reverse biased means it will not conduct. So we have only this much in the circuit. This is 10 ohm. This is 2 volts. What is current? I is V by R. V is 2 upon 10. So 0.2.
Yes, sir.
Answer 0.2. Because they're telling resistance here is 0. So only this resistance forward bias will function. Yeah. हाँ हाँ मैं कल देता हूँ आज टाइम नहीं मिला कल आज नहीं होगा कल
Done, sir.
Okay, 17th done.
Yes, sir.
18 till 20 we are doing today. 18. Current in the circuit shown below is. Tell me first, it is forward biased or reverse biased? This is forward biased or reverse biased? This voltage is low and this is high in comparison. That means there is reverse biased.
Reverse. Yes, sir.
Reverse biased means current will be 0, it won't conduct. Current 0. The option. 19. PN junction can be connected in series by 3 different methods as shown in the figure. If the potential difference is same, then the correct connection will be. Okay. Potential difference in the junction is same only when both are forward or both are reverse. In first case, P is connected to P That means both junction are forward biased in first case. No, both are not forward. In first case, first
One
junction
is
is forward and second is reversed.
Yes, sir.
That means the junction voltage will be different because one is forward, other is reverse. They are not same. Next one. This is not same voltage. P and N. P and N. Now N is connected to N and P is connected to P. So this is also forward. This is also forward. That means same voltage.
Yes, sir.
Third one. This is same voltage here because both are forward. Third this. NP. NP. P is connected to N. So both are reverse biased. Again same voltage because both are reverse, both are forward. Means same voltage at both the junctions. So can I say answer B, 2 and 3 are correct?
Yes, sir.
So 2 and 3 are arranged in such a way that their junction voltages are same. Twentieth. Which of the following is reverse biased? This is P, this is N. 15 means high, 10 means low. So this is forward biased. They are telling it is reverse. Second, D option. -5 and -10. So this is again forward biased because this is high and this is low. Okay.
Yes, sir.
C वाला देखते हैं. Option C. -10 and earthing means 0. So this is high and this is low. That means it is reverse biased. Okay.
Yes, sir.
So this is correct option. See. So tomorrow again same time. Okay, 12:30.
Yes, sir.
So that's all for today.
Yes, sir.
Tomorrow we'll be able to complete this chapter, semiconductor. Please revise and keep everything. One theory is left.